Thank you, everybody, for having me. I'm super excited to do these things. And if you're watching this after the fact, you're watching the recording, totally cool. I'm a OpenAI API ambassador. I'm also a CTO of a company called Maslow AI. I've been doing product and tech things with the internet, search engines, mobile products, all sorts of every which way you can use a computer to do something. I've probably done something in it. I haven't been this excited about tech since probably 2008 and 9 when I was working on Wolfram Alpha. But with OpenAI releasing the API last year, it really got me thinking that we had arrived at a new place in technology. It's not that we haven't done great things in the last 10 years or anything like that. It's just that this is, to me, truly transformative stuff. And as part of that transformation, what I think is coming, I've tried to develop a way of thinking and talking about this stuff in a way that I think will untap things for people in a whole new set of people, but also just for myself. Like, I do think this is a new kind of computing that is unlike anything we've had at our fingertips before. And part of that is, hopefully some of you have been able to go through some of what I put in the OpenAI Slack, or you maybe found me online, or you read some of this presentation. I think we can move away from programming formally to the extent that you can do that to create huge applications or whatever you're doing. I don't know yet, but to the extent that you can now do fairly complicated and useful things without opening a ton of Python scripts or C code or anything like that, I think is very possible. And I think that's very interesting. And it opens up a whole different way of going about this. And it's what I call the Computational Act. And so if you get a chance after this, and if you feel compelled to just go look at the stuff now, if you want to be distracted, I've written quite a bit of stuff, tried to give a bunch of different examples. It may take you a long time to go through, but I have a whole bunch of tutorials and different things out there for you to play with that get you deeper into some of the technology aspects as well as the linguistic aspects of this stuff. But don't get hung up on that, because today what I want to talk about is something I guess more broad and more philosophic. Doesn't mean I'm not going to do some examples and things like that, but I want to lay the groundwork for a different way of thinking in terms of this computational act. So to me, the Computational Act is making sense with computers, making sense between you and the computer, making sense between humans with a computer. So another way to think about that is to correlate systems is to computationally act. So to correlate the language between each other is a computational act. To do mathematics on a computer is a computational act. To have the computer spit out markup language code based on a natural language query is a computational act. We are trying to correlate things we're expressing with behaviors of the computer, and then ultimately, usually, to humans on the other end. In another way of thinking, you can think about this as creating sensations between computers and humans. We literally want to make sense such that some system on the other end or some human can make sense in whatever ways they will of the signal moving through the computer. Why do I frame it this way? Because again, in my preamble, what I think of as formal programming, this idea that we have deterministic inputs and outputs, and that the only way to make a compelling program is to have something that always tells the right answer, or definitely always does the same thing. I think those days are gone. Hopefully most people who'd be tuning into this kind of thing would appreciate that too, because most of the applications and experiences we consume all day long and interact with on the internet, whether it's through Zoom or social media or in Slack or texting on our phones or Snapchat or whatever everybody's using, these are not deterministic experiences. There are correlations between huge amounts of networks of people and computers. And with transformer networks, the technology behind GPT-3, I think we've got a new level of creating, I don't want to call it arbitrary, but arbitrary maps between things and correlating different systems. I think many of you who are probably listening to this or watching this have played with transformers or played with GPT-3, obviously, and you're realizing just how much it opens up to you. So if you want to click on this video, I think it's a very interesting video that we're now able to X-ray computer chips, which why it's related to this point, I want everybody, again, to have a philosophic view of what's going on, that at every layer of computation, whether it's something that's happening inside of you, or it's happening inside the chipset of your computer, or it's happening with the language that you're seeing on your screen, you're just getting layers upon layers upon layers of correlating sensations. And so when you watch this video of this, the X-ray of this computer chip, you'll just see how many layers of computation are actually involved in these high-level things like doing things with GPT-3. But I think the video it's an interesting way to kind of just reset your brain around just what I mean by correlating systems. I've drawn up different schematics and different ways of thinking about it. So some people are visual, some people need diagrams, some people need sentences or whatever. That's the whole point. I try and make my point in as many different ways as I possibly can. So feel free to read some of the definitions that I have on the screen or look at the presentation later on. I try and draw these ideas out with a bunch of metaphors, a bunch of schematics, a bunch of mappings, and then ultimately a lot of different definitions. For those that are more interactive, although I think reading and listening to this isn't interaction, is a computational act. There's a lot of experiences that me and my collaborators have created. Some are using GPT-3, some are using other kinds of technologies and transformer networks and deep learning, all sorts of things. You get a variety of these things. So feel free to scan these QR codes. I purposely do things like QR codes and different modalities to get people to access things so that they're always having to jump through multiple layers of computation to get to the things that I'm playing with. So let me really quickly bring one up here. One of these that you can get to, I'm just going to click on it here. It should be on my screen. You'll start seeing it. Is a thing we call paper. And so this is AI paper, if you want to think about it this way. So GPT-3 is great. You can just start computing with it. And it's kind of a computational flow that just lets you interact with the computer in a very different way, where you're not doing this, what I consider discrete button pushing or typing. It just kind of, even if you stop, it's going to keep going. And you can just sort of interact with this flow. And it's triggering a whole huge amount of machine learning things. And as it warms up, it'll start doing different things. But I can kind of cut this short because I know what the system is. Hold on, I'm bringing up the commands somewhere. Sorry, let me get a new box here. You can just kind of arbitrarily click. Oh, goodness. Where are you? Losing the boxes. So it's doing different things. You're going to have to play with it. And you'll get the hang of it, but I'm not going to explain it too much further. But it's a very different way of interacting with things. And I'll go back to this main Alive machine because we've got a whole bunch of experience. And again, this is for you to play with and flow and compute and do all sorts of computational acts on your own. Another example, just a very different way of doing it. Sorry, turn this on. Just a different modality that's allowing you to map between you and the computer. So we'll just start interacting. You're going to see different things start to happen over time. And again, I'm just orienting you to what's going on here. You don't have to do anything in particular. There's a command palette. So now I can get a bunch of new commands. So if you want to play around on your own, go ahead and do this. Go to the livemachine.io and you can start playing with all sorts of different ways of computing. Again, I'm going to let you explore, but I just wanted you to show that if you go through some of those QR codes, you're going to get a very different kind of computational experience. So let me get rid of that. Just going to minimize this. Okay, great. So go play with that. Go get your mind doing something different, and we'll keep going here. So let's get into this idea of transform. Transformers, I don't know how many of you have gone deep into the technology. This is not something I'm going to do tonight, but I do encourage you, if you have any curiosity about these things, you should definitely go deep into this stuff, because I do think transformers are probably the breakthrough that we've been waiting for in machine learning and AI. I think they're general enough. I think there's a huge community and a huge commercial community around figuring out how far these things can go. I think they work across every kind of signal modality. My experience with technology over the last couple of decades, that there's very few breakthroughs that are actually transformational, and they tend to be very general in nature, and they tend to apply to a whole category of phenomena. And I think transformers are that. So I think if you are technically minded, if you're mathematically minded, it's well worth your effort to jump into these and dig in deep. There's a whole bunch of great tutorials of various levels to walk you through it. I've linked to one here. This X-ray transform is a great infographic. There's a great blog that accompanies it to walk you through different aspects of it in detail. And it'll show you how the whole chain of what leads to these transformers, such as the ones that power GPT-3, how they're actually built, trained, maintained, etc. There's a quote on the screen. It's a little hard to read at this small, so maybe I can blow it up a little bit. But basically, even the folks at Google are saying they're putting transformers in almost everything. In fact, I noticed, and I'll see if I can trigger it in here, transformers are really, you see, even in Google Docs, they have transformer networks that are now doing type ahead in almost anything with text and whatnot. And I think you're going to see this in almost every piece of software. Transformers are just going to be sitting in there, helping us do things. Now, the ones that are being deployed in Google Docs are fairly small, and they're just doing simple type ahead. But I would anticipate that in entire generative capabilities are going to be exposed, and so that you could probably at some point in the very near future, you're going to be able to generate entire presentations just by suggesting a topic, and it's probably going to create the whole darn thing for you. So I don't know how many people know that, or that they've seen that type ahead and those transformers are being deployed everywhere. You might have noticed that Microsoft had an announcement about how they're doing pretty extensive type ahead and generative stuff in MS Word coming up. I think basically anywhere that you might be typing or doing image manipulation or anything, you're just going to see transformers deployed at the small and large scale. So it's worth learning even on that standpoint, because they're going to be everywhere. Which is my point here. If you've never played with transformers in other modalities than text, I encourage you to do so. The Magenta project with TensorFlow.com, they have a wonderful amount of examples of stuff, but they have a particularly cool music transformer that's fun to play with. And again, you get full technical details, but it's very easy even if you're not technical to play with it. And then obviously last week, OpenAI released their latest blog, which if you have not read it, if there's one thing that you could read coming out of this this meetup, I would suggest reading this multiple times and reading the accompanying paper, and go through the code and everything that you possibly can. I think there's a major breakthrough in here that I certainly was anticipating with my own work, which again, these transformers are gonna not just work in many modalities independently, they're going to work across modalities, which means the things you're figuring out how to map inside one transformer is probably going to apply to many other transformers. And so when you go through this, I don't want to spoil this for those of you that haven't read it, but when you go through here, we're finding metaphorical neurons. I don't have a better way to think about it, but we're finding there's convergence points across modalities. And I think it's not going to just apply obviously to images and text, but you're going to get it in sound, and you're going to get it in obviously moving pictures. You're going to get it in vibrations. You're going to color. You're just going to find this everywhere. And if you're a practicing artist, none of this will surprise you, because all sorts of art theories, whether it's color theories or theories of forms and shadows, artists are very adept at using different semantic spaces to make their point to audiences. So I don't think there's any surprise that there's going to be a convergence in the technology that vets very nicely with a lot of our psychological theories, our neuroscience, as well as our art theories. So definitely worth your time. If you do nothing else after this, I would definitely read this. Again, I've said it, I'll say it again. These are generally robust technologies. They're going to work across any signal, I guarantee it. All the big companies are scaling these models up. The open source community is scaling these things up and making data sets available and corpuses, and we're going to get better code bases for you to manipulate these and fine tune these. It's just a good bet, in my opinion, for you to get, at the very least, very conversant with using the technology, even if you don't come to understand the underlying stuff. I think it's going to be so pervasive that we're not going to have to understand all the underlying stuff, but we can just be good stewards on top of it. For those that have a slightly different, they're more humanities-based or linguistics-based, I have some materials. These are books and resources that I suggest if you want to go a little bit deeper into how some of the things that have influenced me and got me to the level that I'm at with this. I suggest some of these books and these thinkers. It's a kind of a mix across the humanities, across philosophy, and across computer science and linguistics. Everything from Derek Parfit, who's one of my favorite philosophers on personal identity and moral philosophy. His view of how identity forms from people, I think, is very important to thinking about how this technology is going to affect us and how to think about using this technology. J.L. Austin probably isn't as well known as a linguist as I think Austin should be, but How to Do Things with Words is an iconic work, and it has informed almost everything I've done with GPT-3. And it's where I'm borrowing this idea of the Computational Act from. While he doesn't talk about computation, he talks about language from the standpoint of performative versus descriptive. And I view computation as a performative act, not as a descriptive act in most places, because you literally are trying to perform things with the computer, and the computer ultimately is going to perform things to other computers and or to your screen. So I think this is very powerful work to help you think about these things. It also will just help tune you better on GPT-3. The Wolfram physics project, I think, is worth, and that's what that little schematic is. It's worth people looking at, because obviously I've been influenced by Wolfram quite a bit myself. But I think the mathematics and the computer science that they're doing as part of the physics project is going to end up being very relevant to the analysis of transformers. So if you haven't checked out the Wolfram physics project, I would suggest doing it. And then you can look at these other resources, and I assume that for the curious, you'll figure out why I'm suggesting them. For those that want to pop through to another thing, I encourage you to play with a fun philosophical thing in GPT-3. Just go ahead and start talking to GPT-3 about time. I think you'll get lost in a fabulously interesting rabbit hole to figure out how you can talk about time with GPT-3 and what that interpretation might be. And for those that are super motivated, I encourage you to figure out how to create a GPT-3 based clock without cheating and using Python or something else. For those that want to follow up on that homework, feel free to hit me up independently, because I'd be very curious what solutions you come up with, how to actually build a clock mechanism with GPT-3. So with that, I want to transition. You can go through the rest of these slides on your own. They're mostly reinforcing points I've already made, but I want to actually go through some things that I think will be exciting to you and reinforce some of these points. So let me get rid of this. on my screen, you're now going to see, I use Mathematica, obviously, because I worked at Wolfram, and I've been a lifelong Mathematica user / Wolfram language user. And I just think it's a natural complement to everything that GPT-3 and these transformers do. I was a convert to functional programming a long time ago. I believe in notebook interfaces and interactive programming. So it has not been surprising to me that Colab and Jupyter has kind of taken the world by storm as far as data science and interactive programming goes. It's also not surprising to me that you're getting a lot of like the proliferation of processing and other creative coding environments also have this interactive element. So just keep in your head, again, this whole idea of computation as a performance, because I think we're only going to see more and more of this, that computation is going to feel more natural as a human performance, and is going to be less opening up a command prompt and, you know, writing a program and then compiling it and hoping it does something interesting. So let's just warm up. Do some very simple things. So 2 + 2 obviously should be no problem for a program called Mathematica. 2 + 2 = 4, 2 + 5 = 7. These probably seem to you as nothing interesting because it's like, well, of course, we all do arithmetic, and that's what our computers and our calculators should do. Okay, but there's another way to do that. If you've ever used Wolfram Alpha, we can do these calculations, but in a different way. We can use natural language to do 2 + 5, and then it has a natural interpretation of the number and the operator sign of 2 + 5. But that also, the reason I warm up with these kind of things is that when you think mathematically, you're not just thinking about the arithmetic symbols. You're actually you've got a lot of other things that you can think about that might be in your mind, or you might have been trained with, or they might have occurred to you very intuitively or naturally. You obviously have the number line and how you can think about jumping through the number line. You can think about the number signs. You can do manipulatives, which is what a lot of kids learn with, is just literally digits and blocks and things like that. You can do comparisons to other things out there. Point is, you can just keep even simple things like 2 + 5 written out can be mapped to a whole bunch of different concepts. And all of these things on your screen, you would view as a valid, what I consider a valid map or a valid computational act. Valid in the sense of being factual, being true, being probabilistically equal to 1. I'm using that kind of language because I'm going to go from mathematical facts and kind of wind us out to things that are less sure, but in a way, to me, are still valid maps, because you can see how we go from our query, our inquiry, our act, to our response. So in the case of GPT-3, so just for those that are curious, I've wired up my Mathematica to all sorts of helper things for me, so I can just call GPT-3 directly in a very natural way. So I have a little function that just lets me call GPT-3. And if I do 2 + 5 =, I kind of mimic what I was doing with Mathematica. I'm going to rerun this. I'd ran it previously, but let's just see what it comes back with. Who knows? This could be very non-deterministic because I'm using the DaVinci engine at my default setting is 0.7. So it's going to come back with probably something weird. So, okay, let's talk through this, because again, using my language, this is a valid computational act. For a language model, a transformer that we haven't told it anything other than 2 + 5 =, these are reasonable things to come back with. It's just showing us other equations, right? It's actually kind of interesting as a discovery tool of like other valid equations. Then it goes on. This is kind of fun when you just let it kind of run. It does all sorts of other maths, which to me, if you track from that Wolfram Alpha example, where if we just use a calculator, we just get the answer, but no context, nothing else interesting. You use some Wolfram Alpha stuff, then you get some kind of interesting things that you can look at. And then if you use GPT-3, it's like you're extending this idea. What we've done is kind of drawn out the conceptual map quite a bit. But maybe you're like, Russ, I don't want any of that. I want just let's figure out how to get to the point here. So let's try and dial this back a little bit and get toward the fact. So we're just going to use the ADA engine, and 2 + 5 = at temperature 0. So What temperature zero means, for those that maybe don't know, is basically try and use the least crazy thing. You could use a lot of different phrases to talk about this, but your temperature zero with these language models and this GPT-3 API is basically trying to say, don't get too crazy, stick with the most probable thing and just bring it back. Well, what's hilarious about the fact that sits in ADA at temperature zero is 2 + 5 = resolves to 6, and then a bunch of nothing about numbers. Let's just change this and see if DaVinci has a more factual basis according to arithmetic. I don't know what will happen here. This better be really good because DaVinci's taking so long. So kind of interesting that it came back with 6 again. And you can sit here and we can read why it might have done that. But let's not get hung up. I'm going to keep going. So here we can start playing with the temperature settings. Let's keep going. Let's up it. Because again, just in your head, just keep in mind, we're doing these computational acts where we're trying to map things. And these are all, quote, valid, but now you're just tuning it. If you want to go to a certain place in the map of possibilities, you got to figure out how to tune it. So here it's like, well, why is it doing this? And in a way, it's just finding combinations of numbers. I can explain this a little bit because I know what's going on in these transformers a little bit, where this actually is a valid map for this very simple sign, where you're just kind of equating a couple of numbers and you're delimiting them by equals and plus. We may not find this good as an interpretation of math, but as far as language signs are concerned, this is a valid interpretation. Okay, I'm going to keep going. Let's try this example that we did with Wolfram Alpha, where we just give it a super simple natural language query, but with number signs. Now, you may be wondering why I'm sticking to the math field, and it's because I find math is such a good place to start because you can be so clear about whether it's right or wrong in terms of facts. So this is such an interesting example where you go 5 + 2 =, and it comes out with 57. And that's actually kind of an interesting, the fact that it's interpreting these as kind of extending the idea. And again, you may want to go and figure out all sorts of how to do arithmetic. I would suggest that doing GPT-3 arithmetic is probably not going to be super efficient. You should just use a calculator. But if you do want to explore these things, you can sort of figure out why it's doing what it's doing. So let's just keep going. Now, let's tighten it up. This is the thing I found that people, when they are trying to figure out how to computationally act with transformer networks, sometimes they miss the obvious. If you want a transformer to do what you want, generally, you just got to repeat yourself. Repeat the format that you're going for. So in this case, I'm just going to fire off again to DaVinci at temperature zero. Instead of just having one equation, one unsolved equation, I'm going to give it 3. I gave it some examples of valid, what I consider valid math, and now it's back on track. Now it's giving you factual answers. And so I want you to think about it. If you want GPT-3 to do a mathematical act, you need to do a mathematical act. This is a powerful concept that a lot of people miss. They spend a lot of time getting very clever with how to tell the computer what to do instead of just showing the computer what to do. This is why I call it computationally acting. If you just think in terms of modeling the behavior you hope the computer will do, you're going to get much further with these transformer models. Okay, so let's extend that. Let's extend this thinking. So I organize computational acts into 3 categories. Simple, a simple computational act, and this is anything that any physical system can do, is just their computations are what they are. They don't have any other context that's necessary. They're a unity. I know this is, I went from giving you examples to doing some philosophical things, so I know this takes some time to think about. But these are just things that mirror things back to you, present things back. And again, I'll give some examples, or you can look at them later. Very simple things where there's not a lot, there's no cause and effect, there's not all this complicated context. It's just mirroring back. And in a way, this video is kind of like that, where it's just a pass through the video signal to you and your video to me. That's a very straightforward thing where there's not a lot of stuff going on. The second category is complex, where you're trying to maintain state, context, you're trying to get to a multiplicity of things. And that's often where a lot of our applications lie and what we actually want to do, which is we want to keep track of things and make a new thing. We don't want to just repeat things, okay? And then the third one is the hardest one to get our head around, but it's actually a lot of what was happening in those examples that seem like they're off, which is these emergent phenomena, where we actually arrive at some new thing that we didn't expect. Some new thing that it's almost like we don't know where it emerged from in what we were doing. Meaning is one of these things. I could get into the whole theory of time and space and how that emerges from this simpler stuff, but again, this is a whole different meetup. We got to have that. But for the effect of this meetup, meaning is what really matters in the emergent. And I say that because almost everything everybody's trying to do with GPT-3 and transformers is to find meaning. And that's always going to be an emergent thing. And to me, too many people are trying to put meaning into the machine learning models instead of realizing it's the thing that happens between people. Okay? So let me quickly go through some examples to kind of build that up. Let's do simple acts. So a simple act with GPT-3, we already did some simple arithmetic and it already got crazy. So let's just go simpler. Let's just put the number 1 in, send it to the ADA engine, and see what it comes back with. At temperature 0, it just repeats 1.0.0.0. I could explain why I think this is happening in the corpus and in the tokenizer and things like that, but you're never going to get a different answer for 1 at temperature 0 than 1 is the prompt and .0.0.0. If I switch engines, let's just go up to Curie. We're going to get the same thing. DaVinci, much bigger model, so it might go somewhere different at temperature 0. Let's see here. I'm almost certain it goes somewhere different. There's another fun thing that's fun to talk about. It's interesting how all 4, this is a very important point, actually, if you want to think about this stuff. It's very interesting that the number 1 produces the same result in all 4 engines at temperature 0. That tells you something about the robustness of the reference of 1 out there and how humans use it. That if you're getting consistent results at different settings, it means that fact is represented a lot in the human corpus. I wanted to talk a little bit about the timing. When you see DaVinci waiting there, that is also an element of the Computational Act. In general, when we're waiting for the computer, it's doing a lot of stuff, but then that waiting starts to do stuff for us. It's actually building up our expectations. So if you're thinking about building applications, you have to consider that while the computer's computing, the person's computing, and that may actually emerge a totally different meaning for the same result if it just takes longer. I'm going to turn the temperature up a little bit and max token just so I can reduce the output a little bit so we get a little faster response. So now upping the temperature, I'm now getting a totally different meaning of 1. Let me try the other engine real quick just to make a point here. So kind of interesting how DaVinci was staying on that dot notation, but now what did we find in ADA? That 1 actually represents software versions in path names to software. It's not able to resolve numbers in the same way. Oh, very cool. I don't use the instruct models much because I know that they've got more stuff in them, but super cool that you did that. So now let's get a little more advanced now that we're into this a little bit. Kind of fun to think about how do you ask these engines for random numbers? Not very interesting at temperature 0, but in a way, the temperature setting is a way to get randomization, right? So now what's kind of interesting, it seems like such a simple query, right? Repeat a random number. I use this example for those that are really into this stuff. Random numbers are surprisingly hard to get out of computers. I don't think many people know this, that it has been a long search for random number generators that are truly random. And there's a whole bunch of computational and hardware reasons why this is hard. So the fact that it's hard to do in a language model should not surprise you. But again, you have to think a little bit harder, but also less hard. So I don't know how random I'm being right now in typing. There's probably some bias in what I'm typing, but remember what I said before. If you want the engines to do something, just do it for them. Whether you consider those random numbers, I don't know. They look pretty random to me. Let's go to DaVinci real quick. I mean, this is a valid way of getting a random number. I bet you if you threw this through a random number test, it would probably say that these are valid random numbers. So in a way, GPT-3 might actually be a better random number generator than a lot of the random number generators out there, which is just a weird consequence of language, to be honest with you. So let's explore. We're going to get a little more advanced here. The color red is a nice effect. I'm just using a sentence here. And much like the example with one, the color red is a nice effect. If you think about it, again, less linguistically, but more as a computational act and what that signal might be, the color red is a nice effect. Probably doesn't have that much representation in these corpuses. Like, I don't know how many people have ever said this sentence, but I doubt there's lots of Wikipedia articles about it. I doubt there's much in there. So in a way, the engines are treating this just as a structure. And it's just repeating the structure back to us. It's not even trying to do anything. It's just mirroring it back to us, right? So we can try and see if DaVinci finds anything different. DaVinci sort of knows what color is, so it can kind of go in a different direction. Now let's just keep going, because it's fun to build these things up very quickly. I think this is actually what happens to a lot of people in interacting with these language models, is that they ramp up very quickly. And I'm okay doing it in this meetup because we've been talking for a while. But I also encourage you that, like, be careful with these language models, because they will carry you down rabbit holes and get you very far away from what you had set out to do. So always try and bring yourself back. This example of mirror is very fun. So mirror, just the word mirror, right? Seems like a very simple word, but it's not. Again, think computational act-wise. Mirror is actually a really complicated thing. It has a bunch of different meanings in software. We mirror websites. We mirror software all over. Mirror is in a mirror of each other. There are many fables and nursery rhymes with mirror in it. So you're gonna get quite a bit of confusing things in here. Let's just double the word, mirror, mirror, right? This should strike you as something from Cinderella or whatever. On ADA, but ADA doesn't seem to have a big enough corpus. If we blow it up to DaVinci, guess what the default thing for DaVinci is? It correctly picks up the fairy tale. So what's interesting about that, again, just track with me on what's going, because I think a lot of people are like, GPT-3 gets things wrong. I go, no, it's giving you a map of possibilities. And so much as it resolves to something that has meaning for you depends on your context. The default context of these engines is the highest probability stuff that humans have put out, on the web. Which again it's like, I know this is for a lot of people who are encountering this isn't a mind-blowing thing, but you have to remind yourself of that constantly, because when it does something that's a little bit different than you expect, you have to remember that's because other people have referenced things like that. In this case, mirror, mirror happens to mean, reference a fairy tale thing. Now, tie these things together, and let's just go back to Mathematica and do something. If I just want a calculator to mirror back what I do, I just type the thing. You can do it with a regular calculator. You can do it with your desktop calculator. You can do it in Mathematica. If I type 1, I get 1 back. And in Mathematica, if I type the word mirror, I get mirror back. If I type the word mirror, mirror, or the phrase mirror, mirror, I get mirror squared back. It's treating everything as a mathematical symbol. Again, go back to how GPT-3 and these transformer networks, you should see some unity in how these things are working. Let's explode this a little bit. So I went, just because I think now we can do a little more advanced computational act, where I'm in the complex bucket and maybe the emergent bucket, where I've put together a little small app here in Mathematica, where I'm going to combine these ideas, and it really helps to be able to move quickly. So this is what's called a manipulate. It's a very simple way to define an interface. So I just wrap GPT-3 around it, and I've got some default prompts that I put in here. So I'm going to go back to, I'm going to go count to 10, have it go to the ADA engine at temperature 0. So let's up that a little bit. So in the case of the ADA engine, and its count to 10 is do some weird population thing. Let's just jump to another engine. Again, a population thing. This makes sense that if you prompt a language corpus with count to 10 as a phrase, that it would be counting population. It seems to me that should make sense. I'm just going to go see. So interesting how it bounces around. Let's do rhyming words and see what happens. So just kind of bouncing around. And again, what I'm trying to do here is not anything in particular. I'm just showing you how to do a computational act, because one of the things I try and encourage people is how to explore the space of possibilities before you get too locked in on what you're doing. So again, here, just fun to play around with why it's doing these things. So here's just making a list of words because it's not seeing that it rhymes. Let's go to DaVinci and let's just see if we can tease it out. At a 0.5 temperature, you're kind of saying you don't really have to pick anything too crazy. Let's go all the way as far as I can go up here. Whoop. Let's go to temperature 1, which means just you're free to go weird. So it's kind of interesting here. Wow, what a fascinating thing. I'd have to figure out why it goes there, but it was willing to start with the list, then go into some root mean square. I mean, I can kind of interpret what these numbers are. And it's just doing some weird math. It's kind of interesting how it was one thing led to another. Okay, so you can kind of get the point. I'm making a really quick interface in which to kit things together and play around with. So in the case of if you're using Mathematica or you're doing something else, remember that you can keep computing on top of GPT-3. You can daisy chain it together. You can do all sorts of things. So in the case of Mathematica, I'm going to go back to this phrase, the color red is a nice effect. And I'm wrapping it in a function called text cases, which in Mathematica is a really easy way for me to interpret. If anything came back in the feed with mentioning a color, just pick up that color and present it on the screen. So let me do DaVinci to see if I get anything more interesting. See if it suggests. So it just came back with red, but I'm going to up the temperature. Now, what's fun about think about all these concepts. Temperature also has a meaning in colors. So let's see if adding randomization, I start to get different temperatures of colors. Nope, just reds. Now let's play with this, see if we get anything else. Colors of the rainbow. I don't know, in Australia versus the US. Who knows? Anybody ever asked that question before? Nothing came back. Interesting. So fascinating. Let's keep going. Wow. What are the colors? Let's ask. Sometimes it's easier just to do that. I'll bet you if I were to look at the output, this is where they're using the playground is useful because you're going to see the output. See, now, again, go with what I'm saying on the Computational Act. If you really want the answer to a question, just ask a question. So that's kind of cool. If I ask for the colors for the rainbow, and it's a super simple function, and then I just get the color. Another subtle point here, because I find too many people are leaving their GPT-3 applications as text instead of transferring them to some other modality. This renders GPT-3 more magical. You could build a whole very simple, let's say you wanted to make some interior decoration application. What are the best colors for a playroom? Let's see if we can get that again. Let's keep asking. Black and white. In the summer, I don't know. Point is keep so interesting. I mean, just by switching modalities allows you to just very quickly conjure applications that would have been unheard of. Like the amount of work that you would have had to do previously, even to make an app this simple, would have been quite painful. You can keep tuning this, right? Just by simply stating things in different ways or feeding it colors. If I were to say, I could put, what are the best colors out of red, green, sky blue, and watermelon? Just gave back those two colors out of that list. It restricted it to that list. So again, if you're tracking with me, this should be pretty amazing to you that you literally can just conjure applications so simply now. I went further. Let me skip ahead because I want to make time for things. Let's see where I want to go here. So I was trying a different example. It's sort of interesting for people who, if you've explored semantic search, you can kind of arbitrarily classify things with semantic search, which I bring up at this point because a lot of what we do when we are computationally acting, whether we're looking for facts or we're trying to build an application or we're trying to be creative, is we often are just trying to classify the world into some sort of interesting thing. So I think a lot of times people default to using the completion endpoint when sometimes the semantic search one, A, will be faster, cheaper, and also sometimes because it's got a restricted surface area, you can actually get more creative faster. So in this case, I'm just going to throw the query dress and give it the options of red, green, or blue with the kind of idea, which is what I'm trying to get at here is what's the most common color of dresses as referenced out on the web. So we just run that. And if you just look at the scores that come back, blue dresses seem to be more popular. So let's do blue. What was that meme that went around? Blue or gold dress? Like, let's see which dress won that meme of what color was that dress. So it looks like the blue dress won out. So we just resolved the mean officially on the internet. So I ran into an interesting example, which would be fun to keep playing with, which is just trying to resolve the color of a stop sign. See if it had that knowledge in it, which again, if you go to where I started this talk with these models being generally applicable to things, we should start seeing there to be convergence between visual ideas and textual ideas. But here it actually can't resolve it very well. I'm not quite clear yet. This is kind of an interesting example to me, which again, I think some people shy away from things that quote are wrong. And I happen to think the things that are wrong end up being the most interesting things to chase down to figure out why that might be confusing in our language models. Okay. So fun, I kept extending it to see if I could guess geometry of different objects in a world based on how people reference it. So kind of interesting. Hexagon and octagon seem to be tied for stop sign geometry. I'm wondering though, if that's less about GPT-3 being confused and more about most humans not knowing the difference between a hexagon and an octagon. And so they referentially, they mix them up quite often. Okay, let me do one more example because it's kind of fun, and then I'll stop. Again, using some of the combined technology here, I'm just going to throw a query. Let's say you want to make a recommendation engine, a restaurant recommendation engine or something, you know, from history. So here I just said, what were the top 10 cities in 1200 AD? And it's going to give me some response back, and then I'm just going to quickly do an entity detection on it and the same thing, and then map it out. So London and Greater London. Let's do for baking bread. Let's get baking bread recommendations for 1200 AD. Oh, came back with nothing, but let's try again. Let's up this to 0.9. Let's go more tokens. And again, hopefully this is kind of instructive where I just breeze through. I don't get hung up on like, did I do it right or wrong or whatever? It's like, let's just go, let's jam. It better come back with something cool. Oh, that's pretty cool, right? So according to GPT-3, those were the best places to get bread in 1200 AD. And again, this is just, it's fun. You can keep playing with it. You can go wire things up to this. If I wanted to call in Wikipedia to resolve some of this and determine, you know, what was going on there, cool. But the other thing that should be, again, you build this whole story up, the fact that I can bounce around, this is one line of code, and I'm able to ask GPT-3 for this and then visualize it. That's pretty incredible with today's technology that we can do that. And it's like, well, what's the value of this? I don't know. I would want to go investigate. I would want to do more computational acts to figure out why is this what's coming up? We can now map our history in a totally different way because we have access to this huge corpus that we've never had access for. So here, let's just extend it and make a fantasy thing. I kind of built this whole thing up. Now I was like, why wouldn't I make this totally bizarre recommendation engine like based on historical cities? I think this would be very fun. So I just sort of put a query in here, best cities for large dragons to sleep, fired it off to Curie. And so it wrote for all you dragon lovers out there, here are the top cities for large dragons. It suggested New York City because it's got skyscrapers and a lot of traffic. So, you know, it maps it. It's like, this is pretty cool that you could just sort of do this. Let me see. Then one last thing, I'll close it with this, and then I'll open up for questions if we've got any time or whatever. One other thing that I do, because again, I think you can extend this as technically as you want to go, or as fun as you want to go. The Computational Act can go in every direction. And for me, the last thing I wanted to do, which is just ask GPT-3 for a theory of relativity, and then I quick get a measure of entropy. So entropy in information theory tells us basically some sense of how much content, how much signal was there in something. So I'm just gonna, in that case, I only asked for 20 tokens, so let me ask for 100. Let me do something to make this a little bit more obvious to people. Response, so I can spit it out. I just want to see what the text is, and then I'm going to look at the. So 3.13 entropy. Now I want to compare. So if I want to make a comparison, theory of QAnon, maybe this is a totally terrible thing that I'm doing here. Response Q. Let's see if the theory of QAnon has more information in it than the theory of relativity according to a default GPT-3 response. This isn't looking good. Meaning, I think theory of QAnon probably has, well, maybe it doesn't. Might have less. Yep, a little bit less. That's good news, folks. That's good news when there's less information in a conspiracy theory. So kind of weird, but also not weird what I just did for you there. This is another way to use GPT-3 is to measure it for just the raw signal that's coming out of it based on your query. That is an indicator of something. And to me, kind of where I wanted to leave you is in that bucket of emergence in what you really care about. Is the point of all this computing what we do, that we get everything right? Or is it that we're trying to do things that are interesting, that get us to learn? And so to me, in the earlier examples that we went through, 2 + 2, it's right. We chased rightness and we got a right answer, but at the expense of interestingness. The stuff that we did later on was more informative and actually made us compute more. So if I were to make a pitch to you, I would try and find a balance in what you're doing, that if rightness is the measure, you're probably going to be doing very uninteresting things. So I'm going to pause there, because that was a lot. So I probably went over time, but extra minutes. So
all good, thanks, Russ. Does anybody else have a question at the moment? Michael or JJ?
That was really, really fascinating. And maybe just a quick question, just to make sure I understand where that was going. I remember kind of in kind of the study of mathematics would almost have to define functions and almost those sorts of aspects axiomatically. So using set theory and so on. But is that what it's trying to almost do in the background? So when you use that very, very early example of 2 + 5, is it trying to use the linguistic corpus to almost deduce what the plus sign is trying to represent, and then go from there?
You know, that your question is deeper, I think deeper than it appears on the surface. Not that you didn't get that, but I think a lot of people who might hear this question later on think, well, that question's not that deep. I go, no, it actually is, because I think your intuition is correct there. I think some of it's such a powerful way to think, and asking it that way, because in a sense, when we're writing prompts, the technical term for what we're doing when we write prompts is called meta learning. We're trying to give GPT-3, or these transformer networks, enough signal so that they can deduce the patterns we're looking for, which is exactly what you do from axiomatic mathematics, is that you create axioms that give you enough meta learning that you can then deduce more complicated patterns. I think some people think mathematical theories are like on some unassailable ground, and that every truth that comes out of them is just truth. And it's like, no. We always have to start every formal theory with a set of axioms that we're going to resolve. We're going to resolve from there on up. And so to me, I'm so glad you asked that question, because I'm afraid to get that technical, people, but I do think using these transformer networks is a way of kind of doing axiomatic maths of anything that we want. And so much as we want those maths to end up somewhere, somewhere that everybody else agrees is true, well, then we're going to have to do some work. But we also can just have an axiomatic process for whatever we find interesting. So yes, in a sense, and if you were to expand to a wider theory here, which obviously I'm very inspired by Wolfram, having worked with him, his whole idea is that most of our mathematics and our way of doing mathematics was an accident of history anyway, and that computation is a much broader concept. And I think the transformer networks have only added fuel to that argument, that there's a whole lot of mathematics that is yet to be discovered that is as valid as the mathematics we've built up before. And that there is no route at which all the, we have the math solved. Instead, there's just ways of getting to different places. So good question, I think. And sorry, I'll finish there. I have spent some cycles, I could give another talk, I suppose, on trying to build a calculus of GPT-3 where I actually can find what people most would recognize as set theory and whatnot. It's in there. And I know it's in there by the fact that this, again, using very technical things, it's likely that these transformer networks are Turing complete, which means anything that can be computed, it can compute. We just have to find out how to do it. It may be painful to find set theory in there, but it's inevitably in there.
Yeah, I think that's the thing that interests me often the most about these advanced AI models that are coming out is, do we know the right questions to ask them? And how do we construct them in the ways to get the actual answers that are of value to us? Because you can throw any question you like into this thing, but what are the questions that we're forgetting to ask, or we don't know to ask?
And that, to some of the power of this, but it's also the danger or the confusion of it, I think, is when you put something, you give a prompt and you start getting stuff back, it immediately starts to shape you, which I find powerful, because you can see in how I work. This is the other reason I work the way that I work in front of people, because I want people to see my own computation where I'm in response, and I'm totally comfortable with the computer going haywire, because I'm always just curious what it's doing. And it gets me to ask better questions. And I think too many people think there's a set of valid questions, and those are the questions, and we should stay in those guardrails. Not that this group has that problem, but I found a wider group of people thinks there's a definition of AI, and those benchmarks, as they've been laid out in every paper, are the only benchmarks. And when I read how we built up the benchmarks on how to evaluate AI, I'm like, this stuff's so limited. It's so limited in how we think about benchmarking it. And I instead err on the side of how far of a journey does it take me on, versus how well does it do with a benchmark that might only have business applications. So that, and your statement here is right. It's like, what are the questions we should be asking? And the space of questions arguably is infinite. And so we're never going to get to the bottom of what those questions should be. And I try not to get hung up on that. And if I do get hung up, I always go back to simple math questions, because you can never exhaust even arithmetic and finding interesting things. So I don't know. I think I'm more playful probably than a lot of people, but I think if you want to get at good questions, you have to play a lot.
Yeah, I'd agree with that. I think the secret, to getting value out of GPT-3 is to play with it, not play with it. If you get the difference, you have to be in a partnership with the AI and trying to work together to get to the understanding you need. It is very much, I find, a relationship in how you go about it.
Yep. And I think that's even all that technology that I was demonstrating earlier is like my own work with my own collaborators is about that, is changing the nature of thinking of computing machines as answer engines, and instead think of them as dancing partners, as conversationalists, not in the chatbot sense, but in the co-exploratory sense.
Mm. Yeah, and look, given that none of these AIs are self-aware, at least as far as we know, they don't explore in quite the same way we do, and you have to appreciate that you can end up in blind alleys quite often, because there is no sense of knowledge behind them. But every now and then they come out with something which is just incredibly valuable in a human sense, without having any concept of what they've actually done. It's
well, and I would argue this, that I find human self-awareness requires a lot of ongoing training. Meaning we ourselves often we're not self-aware all the time. It takes a lot of work to like, you can even think about it now. It's like weird whenever we mention the topic, it's right. All of a sudden you become self-aware. But like when you're in flow, like when I'm giving a talk, I'm not self-aware. I'm just giving the talk.
Yep.
Or when you're dreaming. Right. It's habits are that way. I find dreaming to be that way. When you're dreaming, you're not self-aware, you're dreaming. And self-awareness is actually, it's like, you got to go inward. And so to your statement there where you said we to the extent we don't know if these computers are self-aware, maybe they can't report it, or maybe they're trying to report it, but we can't hear it. And it's like,
Yes.
and to me, and I've come up with a different way of thinking about it, which is I'm less concerned with whether self-awareness is real or not. And I believe that this AI stuff, we should treat it more like a medium, more like radio waves and writing than treating it like being. And I think if we do that and we learn to communicate through it, we're going to be much more effective than trying to give it sentience and, in one sense, give it sentience, but also try and control it. Those things are at cross purposes to me.
Yeah. And they don't really help humans either. Like sentient AI is unlikely to be, a positive force on human civilization. There are just very few scenarios in which it becomes a partner and uplifts us with it versus.
I would give credence to your idea there from the sense that sometimes humans aren't a positive force for the human species. I think the pandemic has shown us that we can have while we're self-aware, we can also be highly destructive.
I also, have a question there is, does self-awareness increase that self-destructiveness? Because you have a self that can now deny reality, whereas a computer cannot deny what it sees in front of it. And an AI can't. An AI sees what it sees, and you might have difficulty getting to what that actually is, but it can't be deceiving itself.
I'm trying to think how to parse that. I think humans are not that different, though. They see what they see. They often can't resolve what's. I mean, it's easy. It's easy to make example. Like, again, I could just go to math. Like, we can't count to infinity, and yet we're perfectly fine reasoning about infinity. And it's like, but that's a positive example of, like believing things that aren't true. Well, it is, but it's also no different than believing non-factual things to a certain extent. You get what I mean there? It's like we can't count to infinity. So there is a little bit of a leap of faith. You could say, but we can reason about it. And I go, I know, but we can, and then we can't. Because when we do algebra with infinities, it's like, it's fine. You're manipulating some symbols and you're sort of getting relationships, but you're not actually reasoning with infinity. You're reasoning with the symbol that's a stand-in for infinity. You're definitely not using infinity. And then we have all these, if you want to go to physical theories, we have all these problems with infinity where we're constantly trying to get it out of there. And so it's a weird example that I'm using, but I'm saying humans come at this a different way. Dogs don't have a theory of gravity, but they have no problem managing gravity.
Or catching frisbees.
Right. And so to me, the idea of knowledge is one that we need to, not that we haven't spent a lot of time on, but I find knowledge as spoken or belief driven, or I say I know something, is less useful than saying I know how to catch a frisbee is less impressive than actually catching a frisbee to me. So I'm just such a weirdo like this, but it's like a computer in a weird way. It's like a computer knows more math than we do because it just does math. Logic gates just do math better than we do, better than most mathematicians do it. So you go, but the computer doesn't know math. I go, well, you also don't know how to walk on 2 feet in your brain. It's, you sort of got that, by the physics of your structure and by this is what mammals do. And so in a way, the things that are fixed action patterns in you don't know any more than a computer knows math. You don't know it any less either. And so to me, it's like, where does this knowledge thing fit? It's like, to me, it's almost an irrelevant question for practical purposes, because I think information and knowledge such that it's important to me is stuff that you can actually use. not stuff that you talk about. I don't know if that's helpful, but to me, I think people get too hung up on presenting knowledge. And again, as somebody who's got a math degree and just been doing this for so long, it's like, look, I wait for a lot of people to get the math, and they don't ever get the math, but they have no problem being successful in what they do. So clearly math, having deep math knowledge is not a requirement, even though most people go, math is the highest form of knowledge. I go, well, then why doesn't everybody have it? I'm not saying they should. I'm saying it's probably not that important in the grand scheme of things. So to me, it's like, tie this together with everything I was talking about. Like, just keep on computing, arrive at new configurations of things, and then such that they're interesting and useful, grab onto them.
Yep. Keep experimenting.
It's not like that. Exactly.
And it's almost the argument to not try to deconstruct how it's doing things at times. You have kind of a good understanding of the transformers, but to try and exactly understand when it will and when it won't deliver a particular output.
I find it's a little bit like thinking about clouds, like understanding the general shape and volume of the cloud is very useful to understand, you know, what it is and what it isn't, but actually specifically pinpointing every raindroplet and particle of dirt in that cloud doesn't actually make you better at understanding how to work with that cloud. And the computer's the same. As long as you know the general parameters and scope of what GPT can do, you can make it do amazing things. But being more specific and understanding it, decomposing it, would not help.
I think you're right. If I could, having a statistical mechanics approach to this is way more productive than looking syntactically at every little thing. And I say this in a very practical way. I find most people themselves don't have a strong enough command of language to evaluate what's good and not. And that's not to say people shouldn't be using it if they're not good at language. I'm saying we're coarse-grained language creatures ourselves. So the fact that I've had so many people send me screenshots of different GPT-3 things that I've done. It's like, this didn't seem to work. It said it different than I would have said it. I go, do you go around correcting other people's language all the time? Like, you don't need to do it with the AI either. Like, if it got you somewhere, then the work is done. But like, this idea that there's a correct way in which to communicate would be, to me, like, oh, there's a perfect definition of a cloud. No, there isn't. There's just clouds, and they're made up of particles and things like that. And you can get hung up on like tracking down every little thing, but you're going to be counting a lot of raindrops and not looking at a lot of clouds.
Yes. I have prompts that I've designed for GPT-3 that work, but I don't know why they work. And I'm okay with that because they work.
In a way, again, this is how I'll harken back to computer science theory. It's the halting problem is real, and we're never going to defeat it. We have proven that the halting problem is there forever. So you're never going to be able to predict when your programs, if they're sufficiently interesting, you're never going to predict when they end. So that's going to show up. And what's so fascinating about these transformer networks is the space has been so widened for what we can do that so have the edge cases for where it's nonsensical. We didn't expect much out of our computers before, so we didn't go looking for edge cases that were interesting.
Yeah, look, I've seen CGI go through a similar sort of curve in a lot of ways because, you know, at the start, computer graphics were very basic, very simple things. Now you can create anything with CGI that looks photorealistic. And the challenge is really coming up with what is it that you actually want to create? You know, can we imagine as much as our creative power allows us? And with you know, transformer networks with AI, we've now reached that point where the AI can do so much more than we can think of it doing, that our challenge is coming up with new problems for it to solve, rather than you know, trying to define how it's useful in what it can do.
Yep. I mean, it's such a that's what's been so fun over the last 8 or 9 months with this is I agree with that statement more than any statement. I agree with that. It's like we've now broken the imagination barrier where we didn't really have a clear picture of where we were going to get, and now that we're somewhere totally different, we really don't know where we're going to get. Because it's like we didn't have the capabilities, so we didn't know how to imagine with the capability.
No.
And I think back, I just think back to how crazy it must have been when Leibniz and Newton were coming up with the calculus, and then after, it's like there was before the calculus and then after the calculus. And it was like we had all of this new capability in which to investigate the world, and it reframed everything. Or for those that are film buffs, I love looking back at the history of film and when we started to make moving pictures, and the more than being a media thing, it gave us a huge philosophic shift. For the first time, we could go backwards and forwards in time, and we became obsessed with, it's like literally time travel starts entering science fiction in the public lexicon because moving pictures allowed us to forward and rewind. It's just so fascinating to think about. We didn't know how to imagine before movies.
Yeah.
The movie in the cinematic way. I mean, I'm trying to think about like what it would have been like to be an illiterate society. We can't even consider that based on what we just went through in the last hour and 20 minutes or so. Could you imagine not being literate as a species? And like how our imaginations must have changed as soon as literacy was widely available, just how different the conversations were.
Yeah.
Yeah.
And we're at the,
and so
and
now
we're still at the bleeding edge of this though. Like to me, it's very much like the internet in 95, 96. Or when you look at the early days of television where they were still doing radio plays on the screen. You know, now the challenge is for us to work out how to use our tools to best effect rather than, than just try and do the things we normally tried to do in the past, because we can do so much more.
Yep.
Yeah, a lot of the things you've been touching on here, as well as your way of sort of curiously exploring different things with GPT-3, makes me think of some things I've been thinking about lately, and like how, like there's no experts before the fact. The Wright brothers were bicycle mechanics before they were, aeronautical engineers. They didn't go to school and learn and, do courses in aeronautical engineering. Like it's hard to know before the fact, like what the pathways are, what the stepping stones are to some interesting new things. So, and like sometimes over theorizing or looking at every raindrop is like, not the right path to these things. You've just got to be sort of curiously exploring.
Yeah, it is. I do, because it's like, well, what are the experts going to be for this? And I think what's been fascinating, because I think beyond just interacting with the API itself, it's the engineering that has now been built up around maintaining these transformer networks, and the fact that there seems to be across a huge number of technical communities some devotion that this is what we're going with. We're going with these transformer networks as the thing we're going to get really good at. And it reminds me a little bit of when we were figuring out what are the operating systems going to be. And we sort of converged on Unix, Linux. You can say, obviously, there's Mac OS and everything else. But at the end of the day, the vast majority of computing is done on Linux computers. And we just sort of agreed, this is the set of things we're going to get good at.
Yep.
And we just started to get good at them and move on. And I think transformers are these things that from being good at supporting, we're going to get experts in that. And from being good at using, we're going to get experts in that. And your flight example is a good one, because it's like, we haven't really designed a new airplane in about 50 years. So it's like, you could argue we've got fighter jets and things like that, but even those are pretty long in the tooth. And it's like, we're just sort of got good at flight as we as we imagined it 40, 50 years ago. And that's okay until we get to the next epoch of things. But to me, it's like, I'm saying yes to that. And I think people should just like, let's get good at the stuff so that we can then get to the next level later. But rather than argue about which methods are right, like this stuff works. Let's go with it and get good at it.
I wonder though.
Yeah, that's the other thing. Theory comes after engineering. There was no aerodynamic theory before flight.
Right.
It was like, they made it, this thing works, I wonder how. And theory often comes after the engineering or after the practical.
Well, and that's my dog example too. It's like the Wright brothers sort of just started trying to fly things before they had a theory. And I'm like, that's usually how it goes. We did the theories are useful, but we often got the utility out of the things before we buttoned up the theory. And some people make bristle at that, but I just, no, I think that's actually, there's a parsimonious explanation for that, which is there's no point in having a theory for things that you don't find useful.
Mm.
But something I find interesting though with AI is that if you look at say flight or you look at some of these other things, there wasn't a widespread awareness of the possibility of that technology before it existed. But like before flight, there were a few people who talked about it. There were balloonists, odds then, but it wasn't in the popular consciousness. Everybody wasn't saying, gee, in 10 years we'll be flying around. It wasn't that sort of thing. But with mass media and the evolution and so on of technology, everybody has a perception of what AI is going to be in the future. So how wrong are we going to be?
Probably pretty wrong. I mean, I don't even know how to be right about it. It's like it's a little bit like, how can you even be right about what humanity is? We've never resolved that. How are we going to be right about something that isn't humanity? And I'm not even trying to throw, it's like weird because I'm trying to be cautious with my kind of questions here because I don't want people to go alternative facts and fake news. It's like, no, I'm just saying there are concepts that kind of forever remain as generating concepts. Again, I always go back to math. I can't help it. Number is a generating concept. We still don't have a good definition of number. We have lots of definitions of number, and all the greatest logicians and philosophers have tackled it, but we really be hard pressed to get a definition of when are we done with the real numbers? What are transcendental numbers? Why do they exist? What are surreal numbers? We've never exhausted our ability to create a new kind of number that somehow isn't like the other kinds of numbers. And so to me, it's like if number can't even be resolved into a thing that, okay, we're done with it, we've got it, then there's no hope for things that are more complicated than number. And to me, that resolution, again, the resolution is not required. Dogs do not have a theory of gravity and they catch frisbees.
Yeah. This has been great. I've got to go.
Yeah, this is awesome. Yeah, thanks for doing it.
Chat again sometime. Cheers.
Yeah, we'll do it again.
Yeah, definitely. I think it's a good time to end it there. I just asked GPT-3 what is the number, so that's what it said back.
It's as good. It's a good answer as anything. I love it. Thanks for setting this up. This was fun.
Yeah, no, thanks very much for that, Russ. Hopefully, a number of people watch it in the recording as well.
Yeah, and I'm happy to do a follow-up or anything in the future, and we can pick a specific topic or anything.
Thank you very much. Thank you, Michael, for sticking around. And we'll end it here. And hopefully, Michael, you might come along in 2 weeks. I'm going to talk about what we've been doing with GPT-3 and how we've been using it in our business. And we'll try and go around the room and solve anyone's problems with it. So thank you very much, and enjoy getting to bed, Russ. Hopefully you will.
Exactly. Yeah, I'm going right to bed.
Okay.
Yep.
Bye, guys.
No, thanks, Russ. Amazing talk.